Hey guys, welcome back. I'm wanting to piggyback on my previous lesson on the population proportion and be able to find a confidence interval for it. I want to wrap up the lesson with this short video right here. Now, as you remember, whenever we found the error bound for a proportion, it looked something like this. All right, so meaning that I had my p hat right here in the middle, and if I'm wanting a confidence interval of the middle, I'm just going to say 90% right here. That means that my EBP was how far I could go to the right and how far I could go to the left in order to get my values right here. I'm just going to again call them A and B. That were my confidence interval. Well, a lot of surveyors are interested in what this N has to be. They like to reverse the problem and make sure they get a sample big enough to obtain a 90% confidence interval, or to get a survey big enough to obtain a 95% confidence interval. Okay? So let's do a little bit of math right here to figure out what we need to do with our equation to get it solved all the way down for N. Okay? I could just tell you what the N equation is, but I want you to believe me on it. Okay? Now, first thing I'm going to do, I'm going to help myself out a little bit, is I am just going to call the EBP just E. I'll bring everything else down. So really easy first step. All right? So I got that to be E. Now, I'm going to go ahead and divide both sides by my z-score right here. All right, so I got E over Z. It's going to equal this. Well, it's a standard deviation equation. Obviously not going to be able to solve for N this quickly. Okay, so I'm going to come over here to this other column and work it. I need to get rid of this big square root, so I'm just going to simply square both sides. So my E over Z is going to be squared now. And that will get rid of my square root on the right. Now from here, there's several different things that we could do. Okay, some of you know my story about moving the hat. We could definitely just move the hat and set it on this side. Or I could take the reciprocal of both sides. I could flip both sides and then multiply by P times 1 minus P. Well, either way, what it's going to have me come down to is P hat times 1 minus P hat over, I'm going to split apart that squared. E squared and then Z sub alpha over 2 squared. So just move that squared inside. Square the top, square the bottom. And this would actually be solved for N. That's kind of nasty right there, because of the fraction inside of a fraction. I'm not a big fan of fractions inside of fractions. And so I'm going to rewrite this. I'm going to have N equals, and I'm going to, remember, dividing by a fraction is the same as multiplying by the reciprocal. So I'm going to multiply by the reciprocal. That's going to bring that Z sub alpha over 2 up to the top with the P hat times 1 minus P hat. I'm going to get rid of that parenthesis. That looks weird. Times P hat times 1 minus P hat. All over. And the only thing I have on bottom now is Z squared. And so this would be something great to put on top of your practice problems for tonight. A note card, if you're carrying a note card in for this next test, just stuff you have to know. I assure you, if we're in this classroom, whenever you are taking your next assessment, it will be on the board. But definitely see some questions like this, not only on the up-and-coming assessments, but also on the final. Now, suppose a mobile phone company wants to determine the current percentage of customers age 50 plus who use text messaging on their cell phones. How many customers age 50 plus should the company survey in order to be 90% confident that the estimated sample proportion is within 3 percentage points of the true population proportion of customers age 50 who use text messaging on their cell phones? All right. So I'm just looking for N here. I want to know how many people I need to survey in order to get this sweet 90% right here. All right? It's going to be quite a few that I need to survey. That's why yesterday we were surveying 500, 250 people. And so I'm just looking for n. And I'm going to go ahead and hit my easy button on this one for this 90%. Okay. Very first thing it wants is my z sub alpha over 2. So I go back to my table, and z sub alpha over 2 is going to be, for 90%, it's going to be right here. Okay. Again, I can go to the table and find it, but we're done with a lot of these values up here in the table. The values that I'm going to need are going to be down here at the bottom. So I'm going to pull out this 1.645 and put it in for my z. 1.645. And careful, I need to square that. I think the next easiest thing to find is going to be the e that goes on bottom. Okay? The e on bottom, I'm going to be able to find right here, 3 percentage points. However, be super careful. Number one wrong thing people do is they put a 3 down here. That's 300% if you put a 3 down there. I'm wanting 3 percentage points. 0.03. I'm just wanting to be within 3% on my error on it. Okay. Now, they don't tell me anything about a p and how many I'm expecting to have. If they don't tell me that, the best number I can use, the best guess I can have is 50%. And if I do 1 minus 50%, I get 50%. That's the best number I can use if I don't have any prior knowledge on this. That's going to allow me for the most margin of error on it. If I take 0.5 and multiply it by 0.5, it gives me 0.25. If I use anything else for p, if I was to use 10% or 20%, I would get something smaller than that there. So this is going to allow me for the most margin of error is if I use that 50% right there. It's kind of weird, but that's the way the book uses it. And so I just got this giant calculator problem now. I just want to do 1.645 squared. I'm going to multiply that by 0.5. I'm going to multiply that by 0.5 again and divide it by 0.03 squared. And so I end up with 751.6 people. Well, it's hard to ask 0.6 of a person, so we get 752 people. Hey, it's a plug and chug. We like plugs and chugs, all right? So we just plug it into our formula, get this, get our number, and we don't really need an interpretation on it. That kind of tells itself. How many people do I need to survey? 752. If I do that many, I should be safe with a 90% confidence up here. I'm going to turn you loose on this one. I'm going to see what you can do with it. All right? And so go ahead and hit pause on the video, and I'll work it out, and you work it out, and then we'll compare to see what each other did. All right, a couple things to talk about here. First of all, never click on an ad on your smartphone. I did one time, and I ended up in the mail with this tooth whitening kit that cost me a lot of money, and it was a mess to get through. All right. Second of all, I'm using 0.5 again. Okay, now if they had run a prior study on this and found that, I don't know, 30% of people click on ads, then yes, I think using 0.3 and 0.7 would be smarter right there. I wouldn't have to ask as many people, but I don't have that knowledge. So I'm just going to assume 50% of people do, 50% of people don't, and that's going to inflate my number a little bit to make sure I cover enough people. Third off, the answer to this is going to blow your mind a little bit. The answer to this is going to be 385. On these where I'm finding n, I always have to round up. If I always round up, if I was to round down to 384, then I'm not taking into account this person I need to ask. Okay, so this is like the smallest number I need to ask. If I take this down to 384, then maybe I'm only got like a 94% confidence will be the most I can max out at. Probably not, but it's always a good idea to round up. every time. Okay. And so hopefully the answers on the practice problems will reflect that as well. All right, just a couple of these to try on your own. I think you should be good with them. Have that formula somewhere handy, and we can talk about these later if we need to. Have a good day.